Hi everyone, today we are going to see about operating system. In operating system, we are going to see about memory management. So let us see what is memory management. The virtual memory is a storage scheme that provides user an illusion of having very big main memory. So this is done by treating a part of secondary memory as the main memory. In virtual memory, the user can store processes with a bigger size than the available in the main memory. Therefore, instead of loading one long process in the main memory, the OS loads the various parts of more than one process in the main memory. The virtual memory can be implemented via demand paging and demand segmentation. So virtual memory, it gives that they are moved to here until they need to be executed, and then computer programs are stored here, that is main memory. For example, let's assume that operating system requires 300 MB of memory to store all the running programs. However, there are currently only 50 MB of available physical memory stored in the RAM. So the operating system will then set up 250 MB of virtual memory and use a program called virtual memory management to manage the 250 MB. So in this case, the VMM, that is virtual memory management, will create a file on the hard disk that is 250 MB in size to store extra memory that is required. The operating system will now proceed to address memory as it considers 300 MB of real memory stored in RAM, even if only 50 MB space is available. It is the job of the virtual memory management to manage 300 MB memory even if just 50 MB of real memory space is available. Paging. In operating system, paging is a storage mechanism used to retrieve process from secondary storage into main memory in the form of pages. The main idea behind the paging is to divide each process in the form of pages. The main memory will also be divided into form of frames. So let us consider the main memory size 16 KB and frame size is 1 KB. Therefore, the main memory will be divided into collection of 16 frames of 1 KB each. There are 4 processors in the system, that is P1, P2, P3 and P4 of 4 KB each. Each process is divided into pages of 1 KB each so that one page can be stored in one frame. This is the example picture of the paging. Here paging hardware is given. A page table is used by virtual memory system in a computer operating system to store the mapping between virtual address and the physical address. Thus, the table mainly provides the corresponding frame number, base address of the frame where the page is stored in the main memory. Page replacement algorithm. In operating system that uses paging for memory management, a replacing algorithm is needed to decide which page need to be replaced when new page comes in. Page fault. A page fault happens when a running program accesses a memory page that is mapped with the virtual address space but not loaded in the physical memory. Since actual physical memory is much smaller than virtual memory, page faults happen. In case of page fault, operating system might have to replace one of the existing pages with the newly needed pages. Next one is first in first out page replacement algorithm. This is the simplest page replacement algorithm. In this algorithm, the operating system keeps track of all the pages in the memory in a queue. The oldest page is in the front of the queue. When a page needs to be replaced, in the front of the queue is selected for the removal. Example, consider a page referring using the string 130356 with 3 page frames. Find the number of page faults. So optimal page replacement algorithm. In this algorithm, pages are replaced which would not be used for the longest duration of time in the future. Consider a page reference that are given with 4 frames. Find number of page fault. Next one, the least recently used page replacement algorithm. In this algorithm, page will be replaced which is least recently used. Consider a page reference string with 4 page frames. Find number of page faults. Not recently used page replacement algorithm It favors keeping pages in memory that have been recently used. The operating system divides the pages into 4 classes based on usage during the last clock tick. Referenced modified, reference not modified, not referenced modified, not referenced not modified. The second chance of page replacement algorithm is called clock replacement policy. Add a second chance bit to each memory frame. Each time a memory frame is referred, set the second chance bit to 1. This will give the frame a second chance. A new page read into memory frame has the second chance bit set to 0. When you need to find a page for removal, look in a round robin manner in the memory frame. The second chance bit is 1. Reset it second chance bit to 0 and continue. The second chance bit is 0. Replace the page with the memory frame. This is the example for a second chance replacement algorithm. A second chance replacement algorithm consists of page request summary also. And next one is the clock page replacement algorithm, that is modified version of first in first out. The set of new frame candidates for replacement is considered as a circular buffers. Input devices are the pieces of hardware used by the human to communicate with the computer. For instance, a keyboard or a mouse is the input device for the computer, while monitor and printers are the output device. The types of input-output devices are block device and the character device. A block device is one of that stores information in fixed size blocks. Example, hard disk, CD-ROMs, USBs. Character device is a device which delivers or accepts the stream of characters. Example, serial port, parallel port, sound card, etc. Device controller. The device controller works like an interface between device and the device driver. Input-output units such as keyboard, mouse, printer, etc. typically consist of mechanical component and an electronic component, where electronic component is called the device controller. Next one is the interrupt handler. Interrupt is when a process is executed by CPU and when the user requests for another process, then this will create disturbance for the running process. This is called as interrupt. So the interrupt cycle is given. The first one is starting the cycle, and then we go for the next one, and then there we have to fetch for the intermediate cycle. So what happens means the running process will be slowed down. That is called as interrupt. Thank you.